Dear students, we have already started with electrochemistry chapters and our today's topic is commercial batteries. You already know these are electrochemical cells which convert chemical energy into electrical energy. So we are talking about galvanic cells which are commercially used. Why they can be used as battery? They are the ready-made source of energy. They are very light and compact. Um, they provide proper power for a longer period of time, and some of them are rechargeable also. Children, whatever the reaction which is occurring in the battery is a spontaneous reaction. We have already discussed that delta G is negative for all such reactions. These batteries can be further classified into mainly of two types. One is primary, other is secondary, and one more class we can say, that is fuel cells are there or fuel batteries are there. You know what is the difference between batteries and cells? I've just used a term fuel cell or battery. Batteries are a combination of cell. When many electrochemical cell or galvanic cells are connected in series, they are called as batteries. What is the difference between primary and secondary? You know, and I'll deal fuel cells separately, but primary cells or batteries are those which can be used only for a short period of time, which cannot be reused, which cannot be recharged. So I'll write down here, they can't be recharged. Such cells, as they cannot be recharged, so they cannot be reused. So they are a kind of cell which are use and throw kind of cell, whereas secondary cells are those which can be recharged by passing external source of current, and hence they can be reused. And fuel cell, I'll discuss it in detail later on. There are two types of primary cell which we are going to discuss. One is dry cell, other is mercury cell. There are two secondary cells which we are going to discuss. One is lead storage battery, and another one is nickel cadmium battery. And fuel cell, there is only one which is in your syllabus, that is hydrogen oxygen cell. So children, today's outline is we are going to discuss 5 cells. One is dry cell, mercury cell, lead storage battery, nickel cadmium battery, and hydrogen oxygen cell. Even if I am using the word cell, it means when they are combined together, many cells are combined together, they will give rise to a battery. Let's start with dry cell or dry battery. There is a zinc container. This is zinc container, and this will act as anode, which is negatively charged in all electrochemical cells. There is a carbon rod which is kept in the center of it, which is further surrounded by manganese dioxide. So I'll say this is carbon rod or graphite rod, which is surrounded by manganese dioxide, and together this is acting as cathode. And the space between anode and cathode is having a paste of, this space is filled with a paste of ammonium chloride and zinc chloride. You know, zinc chloride is absorbs moisture and it prevents corrosion also. So this is a kind of, you can say, electrolyte also. Now what happens at anode and cathode? All the reactions we are going to discuss. Let's talk about what happens at anode. Zinc container is acting as an anode. Zinc, it undergoes oxidation because oxidation occurs at anode. Oxidation means loss of electron. It is also called as increase in oxidation number. Let's see, zinc changes to zinc ions with the loss of 2 electrons. So here it is 0 oxidation number, whereas it is plus 2. So increase in oxidation number, as well as it is losing 2 electron. So at anode, zinc is undergoing oxidation. See what happens at cathode. You know, it may be any cell. Reduction occurs at cathode and it means gain of electron, or you can also say decrease in oxidation number. In this case, MnO2, this is acting as cathode. Ammonium chloride here ionizes to give you ammonium ions and chloride ions. So at cathode, MnO2 along with ammonium ions undergoes reduction. See, it changes to MnOOH, and ammonium ions changes to ammonia. Let's find out the oxidation number change. Here the oxidation number of manganese is X. I'm showing you how to find out the oxidation number. This is X, plus 2 oxygens are there, each one is minus 2. This is a neutral compound, so equal to 0. Here oxidation number of manganese is 4, whereas in this case it is X minus 2, and OH is having the oxidation number minus 1. It's also a neutral compound, so here it is plus 3. It is changing from plus 4 to plus 3. There is decrease in oxidation number. So how many, what is the change in oxidation number? 1 electron change is there. So I'll write down here 1 electron. Beta, there is an easy way to learn that on which side you will write down the electron. In oxidation you write down on right side, but on reduction you need to write down on the left hand side. But how will you remember this? There is an easy technique. And the technique is, wherever the oxidation number is more, that side you will write down the electron. Here it is plus 4, here it is plus 3. So you'll write down the electron on the left hand side where the oxidation number is more. Even in this case where oxidation is occurring, here it is 0 and here it is plus 2. Oxidation number is more on this side. So electron you will write down on the right hand side. So remember this, जहाँ भी ऑक्सीडेशन नंबर ज़्यादा हो रिएक्टेंट या प्रोडक्ट की तरफ, उसी साइड पे इलेक्ट्रॉन्स लिखने हैं. So this is gain of electron as well as there is decrease in oxidation number. So this is undergoing reduction. Can you write down the overall reaction? Overall reaction should not contain any electrons. It is losing 2 electron, but here there is only gain of 1 electron. So you have to make the electron change equal, multiply whole of this reaction by 2. As such, the two reactions are balanced, and if you multiply this by 2 and add the two reaction, you will get here Zn plus 2 MnO2 plus 2 ammonium ions. There should not be any electron in the overall reaction. Here also now it is 2, and right hand side also it is 2, so it get cancelled, and finally you get here in the product side it is Zn2 plus 2 MnOOH plus 2 ammonia. Children, there are 6 things which you need to learn in all these cells. One is who is anode, another is who is cathode, what is an electrolyte, and what are the reactions which are occurring at anode, cathode, and overall reaction. These 6 things in each of the cell you need to learn: anode, cathode, electrolyte, and reactions which are occurring at anode and cathode, and finally the overall reaction. The cell voltage or cell potential provided by the cell varies from 1.25 to 1.5 volts. Children, you know, ammonia gas which is liberated in this process, it reacts with the zinc ion which is produced during the anodic reaction, and the two react together, zinc ions as well as ammonia gas, and they make a complex which is Zn NH3 whole twice Cl2. This is diamine dichlorido zinc 2. So the nomenclature you will study in the next chapter, after inorganic chapter, which is coordination chemistry. Beta, there is a problem of leaking in the dry cell. You might have seen that during the usage, as well as even if you keep it as such, then also they start leaking. There is some white material is deposited here. You know, in this case, ammonium chloride, which is present here, ammonium chloride is a white substance. This reacts with the zinc container, and zinc get corroded in this process. This is an acidic substance. Why I am saying this is an acidic substance? Because it is made up of ammonium hydroxide and HCl. HCl is a strong acid, ammonium hydroxide is a weak base. So ultimately it is acidic salt. So this acidic salt react with the zinc container which is acting as anode, and they make some reaction is occurring, and due to which some white material, white stuff, salty white stuff comes out, and which spoils the battery, as well as it spoils that device, electronic device in which these cells are placed. So in order to stop this, many times you might have seen this is a dry cell. If you remove this coating over it, you will see there is a zinc container inside. So zinc container is further coated with or covered with another sheet of some metal, which is a cheap metal, or sometimes by plastic, thin sheet of plastic also, so that even if some leakage is there, that leakage can be prevented, and that may not spoil the device in which these cells are adjusted. Children, do you know why do we call them as dry cell? Because in this case there is no liquid solution, there is no aqueous solution. The electrolyte used is also a paste. That is why they are called as dry cells. And you know, once the reaction has happened, like zinc has been converted to zinc ions, and manganese dioxide has been converted into manganese oxide hydroxide, then the reaction cannot be reversed. So they cannot be recharged, they cannot be reused. So they are use and throw kind of cell. That is why they are called as primary cells. Children, these kind of cells can be used in toys or a wall clock, or maybe in cameras. In previous days they used to be there also. And now we'll move to the second type of cell, which is mercury cell. It is also a kind of primary cell. They are also called as button cell. Second is mercury cell. You might have seen these button cells. They are very small, and because they are of the shape of button, that is why they are called as button cells. They are used in hearing aids, in your watches also they are used, and you can find out other places also where they are used. Even if you see the diagram, it is you can open it and find out, but it is very small, it is difficult to show. But here if you see in NCERT, so you can find out the anode, cathode and electrolyte. They are represented like this. I'll tell you again 6 things in this cell also, like what is anode, cathode, electrolyte, and the reactions which are occurring at anode, cathode and overall reaction. So in such cells, I may write down here uses also. It is also important, but because once in CBSE they asked the name of the cells based on their usage in daily life. So they are used in hearing aids and watches. They are also called as button cell. In this case, anode is actually zinc amalgam. Mainly zinc is undergoing reaction, and amalgam, which is mercury, is the medium which is provided in this case. And cathode here is mercuric oxide along with carbon powder. So this is a paste of mercuric oxide and carbon, and electrolyte taken is, it is KOH along with zinc oxide. So this is acting as an electrolyte. KOH generally ionizes to give you K plus and OH minus. It is a strong electrolyte. See what reaction which occurs at anode and cathode. Anode in this case is negatively charged. You know, oxidation occurs at anode. So anode is zinc here, zinc. As this reaction is carried out in basic medium, so I'll write down zinc in basic medium changes to zinc oxide. Just balance the reaction. All redox reactions are balanced in a particular medium. This is a basic medium by addition of water on either of the side. So I'll write down water on this side, and you see how I'm going to balance this. If I write down here 2, so now it is balanced, 2 hydrogens and 2 oxygens on both the side. Let's find out the change in oxidation number. Here zinc is in the elementary state, it is 0, but here it is in +2. Oxygen is -2, this is +2. That is why it is a neutral compound. There is increase in oxidation number. So it is oxidation, and oxidation means loss of electron. How many electron it is going to lose? 2 electron, because change in oxidation number is of 2 electron. Otherwise also, as I have told you earlier, which side you will write down number of electron? Wherever the oxidation number of the element is more. Here it is +2, here it is 0. So we'll write down the electrons on the higher oxidation side. See what happens at cathode. It is the positive terminal, and you already know it may be any cell. Reduction occurs always at cathode. Who is acting as cathode? Mercuric oxide, HgO. You know, if HgO changes to Hg. In this reaction, you see the change in oxidation number is +2 to 0. So there is decrease in oxidation number. It means it is undergoing reduction. Reduction means gain of electron. How many electron it is going to gain? 2, because change in oxidation number is 2. And otherwise also 2 electron will write down on that side which has higher oxidation number, which is the reactant side. So it is gain of electron, it is reduction, and you again balance the reaction by addition of water and OH minus on both the side. So if I write down here 2 OH minus and 1 water molecule here, you see 2 oxygens here, 2 oxygen here, 2 hydrogens and 2 hydrogen. This reaction is also balanced. How will you write down overall reaction? There is no need to multiply any of the reaction by any number, because in both the cases 2 electron changes there. So in overall reaction they are going to cancel, and finally you get here zinc. 2 OH minus also get cancelled, water also get cancelled. So final reaction is zinc plus HgO gives you ZnO plus Hg. As I have told you, you are supposed to learn 6 things in each cell. Who is anode, cathode and electrolyte in a particular cell. What is anodic, cathodic and overall reaction. So that we have done. What is the voltage provided by this cell? The cell voltage is constant in this case, and that is 1.35 volt. It doesn't provide a varying voltage. So this is also an important question, because in board they ask, why does mercury cell provides a constant voltage? Answer is, can you see here, there are no ions in this overall reaction. They all have been eliminated. So in the overall reaction has no ions. बेटा अगर आयंस नहीं होंगे तो ये इतना रिएक्टिव नहीं होगा, स्टेबल रिएक्शन होगा. सो दिस रिएक्शन इज occurring with a constant speed, so voltage also remains same. So overall reaction has no ions, so that is why it provides a constant voltage. Whereas in the previous case, if you see, there are ions like this, zinc ions are there, ammonium ions are there, so that is why it provides a varying voltage of 1.25 to 1.5 volts. And you already know the usage, they are used in hearing aids and watches. Children, let's start with secondary cells. What are secondary cells? Let me tell you again. Secondary cells are the cells which can be recharged by passing direct current through them in the opposite direction, and they can be reused also. So first secondary cell which I am going to discuss here is lead storage battery. Here I'll take a combination of 3 cells which will provide a voltage of 6 volt roughly. So I'll take a container in which beta, these 3 electrodes, they are made up of lead, spongy lead we say, it is spongy lead, and they will act as the anode. These 3 are connected with each other, and this template will act as anode, which is negatively charged in this case. And these 3 are also connected with the same template, and this is cathode, this is positively charged, and they are also lead but filled with lead dioxide, PbO2. These 3 together will be called as cathode, and the electrolyte here taken is sulfuric acid, which is 38% W by W, mass wise I am saying. Children, in this cell, let me revise. Who is anode? Anode is lead actually. It is on this side, spongy lead. Who is cathode? Lead filled with lead oxide is acting as cathode. And who is an electrolyte in this case? Electrolyte here is sulfuric acid. And all these electrodes, they are separated by fiber glass sheets. So this is the kind of arrangement which is there in lead storage battery. You know where are they used? They are used in vehicles, that is in your car batteries are there. Even if you have inverters. So generally they are used in cars as well as in inverters. They are rechargeable cells. I'll explain it. So let me explain the reaction which is occurring in this cell. See what happens at anode. Lead, which is acting as anode, will react with the sulfate ions. बेटा सल्फेट आयंस कहाँ से आएंगे? आपको पता है सल्फ्यूरिक एसिड इज एन इलेक्ट्रोलाइट. इट आयनाइजेस टू गिव यू 2H plus and SO4 2 minus. So lead, which is acting as anode, will react with sulfate ions which are present in the solution and will be converted to PbSO4. In this reaction, if you see, here the oxidation number is 0 and here the oxidation number of lead is +2. Why +2? Because sulfate is 2 minus, so lead is +2. What is the change in oxidation number? It is 0 to 2. There is increase in oxidation number, so it is undergoing oxidation. Oxidation means loss of electron. How many electron it is going to lose? 2 electrons. And why I am writing 2 electrons on this side? Because it is loss of electron. Other way also you can say the oxidation number here is more as compared to on the reactant side. So I will write down 2 electrons on this side. As I have told you, where will you write down electrons? Wherever the oxidation number is more. So it is undergoing oxidation, loss of electron as well as increase in oxidation number. See what happens at cathode. PbO2 is acting as cathode. So this also reacts with sulfate ions and changes to PbSO4. See what is the change in oxidation number in this case? If you find out X for lead, there are 2 oxygen. Each oxygen is -2 equal to 0. So X comes out to be +4. Here oxidation number of lead is +4 and here it is +2. So there is decrease in oxidation number, and decrease means reduction and reduction means gain of electron. Otherwise also electrons we write down on the higher oxidation side, which is here on the reactant side, which is +4. Now just balance the reaction. This reaction was already balanced, but here if you balance it, you will get here there are 2 more oxygens here, so I'll write down here 2H2O and here it is 4H plus. Now it is a balanced chemical reaction, and in both the cases it is 2 electron changes there, so no need to multiply any of the reaction by any number. See what is overall reaction. Add the two, you get here Pb plus PbO2. 2 sulfate molecules are there, 2 sulfate. Electrons get cancelled. You get here PbSO4, 2 molecules plus 2 water. Beta, in this case you can see here anode, which is lead here, gets converted to lead sulfate, which is the white powdery substance, solid powder, which get deposited over anode. Similarly in cathode, this is also getting converted to lead sulfate, which also get deposited to cathode, which is made up of lead dioxide. Children, due to anodic and cathodic reaction, you will see that all the electrodes, 3 anodes and 3 cathodes, are coated with lead sulfate powder due to this kind of reaction. So in order to increase the efficiency, now there is a need to recharge the cell. Now the cell is not functional, it is not working properly. So second part is a recharging of lead storage battery. बेटा पहले वाला क्या था? ये जो पहले वाला था इसको हम बोलते हैं डिस्चार्जिंग ऑफ सेल. Discharging of battery. ठीक है, because continuously the reaction is occurring, chemical reaction is occurring, and at the expense of chemical reaction some electrical energy is produced which is responsible for carrying out the different mechanical functions. But now this lead and lead dioxide is covered with lead sulfate, no more reaction is occurring further, so there is a need to reverse the reaction, which this process is called as recharging of battery. So how will you recharge this? You will connect it through external source. So क्या करोगे इसमें? Connect it to external source of direct current. Generally which has a voltage of greater than 12 volt. So we connect it to this. So one part is this. What happens during this process? Electrons flow in opposite direction. Now as you have connected it through the external source, now it is no more an electrochemical cell. Now it is converted to electrolytic cell. What happens in this process when you have connected to the external source, direct current? When you have connected this electrochemical cell to the external source, then reaction will be reversed. Now at the expense of electrical energy, some chemical reaction will occur. Now see what happens at anode, which was previously anode, will act as cathode. Why? So I'll write down the reaction at cathode. This reaction will be reversed. This reaction get reversed. कैसे? PbSO4 which was deposited on anode will now be converted back to Pb and SO4 2 minus with the gain of 2 electron, because now previously which was anode, now it is acting as cathode. Why? Because now it is gaining electron, and gain of electron is reduction. So here रिडक्शन इज अकरिंग. बेटा इलेक्ट्रोकेमिकल सेल में जो एनोड था, जो लूज कर रहा था इलेक्ट्रॉन, जहाँ पर ऑक्सीडेशन हो रहा था, जैसे ही हमने बाहर से एक्सटर्नल सोर्स से करंट प्रोवाइड किया, रिएक्शन हो गया रिवर्स. जब रिवर्स होगा तो दिस विल गेन इलेक्ट्रॉन, एंड गेन ऑफ इलेक्ट्रॉन इज रिडक्शन, एंड रिडक्शन कहाँ होता है? कैथोड पे. सो नाउ दिस विल एक्ट एज कैथोड. एंड यू नो इन इलेक्ट्रोलिटिक सेल कैथोड इज कनेक्टेड टू द नेगेटिव पार्ट ऑफ द connection. So this reaction will occur at cathode. What happens at anode? जो रिएक्शन पहले कैथोड पे हो रहा था अब वो एनोड पे होगा, बिकॉज नाउ द रिएक्शन इज रिवर्स. जब ये रिवर्स हो जाएगा इट विल लूज 2 इलेक्ट्रॉन, एंड लॉस ऑफ इलेक्ट्रॉन इज ऑक्सीडेशन, एंड ऑक्सीडेशन विल occur at anode. In case of electrolytic cell, anode is positively charged. This is connected to the positive terminal of the external source. So here the reaction reverse कर दो बेटा. This becomes PbSO4. This gains 2 water molecules, changes to PbO2 plus sulfate ions are formed, plus 2 electron is there, and here oxidation occurs because it is losing electron. Now you see both lead sulfate which are deposited over cathode and anode, due to passing of electricity from the outer source, external source, will be converted back to lead and lead dioxide. So now lead and lead dioxide has been regenerated and they are ready to be reused again. So why it is a rechargeable cell? During the discharging of battery, you know, continuously lead and lead dioxide, the 2 electrodes, anode and cathode, get deposited with lead sulfate, the white powder, and their efficiency keeps on decreasing. But after some time, when they are connected to the external source during the process of recharging of battery, when they are not functioning properly, then the reaction is reversed and again lead and lead dioxide is regenerated. This is called as recharging of battery. Beta, in your cars also, when you start the engine, there is discharging of battery which occurs. But when the car is in motion, then you see engine powers the alternator, which produces enough electrical energy to recharge your battery. So during the running position, during the moving position, simultaneously discharging and charging of battery keeps on occurring. Beta, lead storage battery get discharged also, as well as it get recharged also. So they are called as a rechargeable one or secondary cell, because they can be recharged as well as can be reused. Children, let us discuss the second type of secondary cell, which is nickel cadmium storage cell. Nowadays they are very popular because they are used, one is they are used in calculators, and they have longer life than lead storage cells. And another is, though they are expensive, but as no gas is produced, and in this case also you will get the products which stick to the electrodes, as there was in the previous case, so they also can be recharged. So in which cases we can recharge? Where there is no gas is produced and the material which is the end product sticks to the electrode, so that the reaction can be reversed. Again we'll learn what is acting as anode in this case. Anode is cadmium and cathode is nickel dioxide, and electrolyte here is aqueous QH solution. See what happens at anode. This reaction is taking place in the basic medium. K plus and OH minus is produced. At anode, cadmium in basic medium changes to cadmium hydroxide, and you know in this case it is the oxidation number is 0 here and it is +2 here. Why? Each hydroxyl ions have -1, so it is +2 here, and it loses 2 electron. You already know increase in oxidation number is oxidation, loss of 2 electron is there. Otherwise also here the oxidation number is more, so I'll write down electrons here. See what happens at cathode. Reduction occurs at cathode. Nickel dioxide changes to nickel hydroxide. Find out the change in oxidation number. Here it is +4. X plus 2 minus 2 equal to 0. And here it is, each hydroxyl has -1. 2 hydroxyls are there. So it is +2. So it will gain 2 electrons. And if you balance the reaction, it comes out to be, in basic medium I'll write down 2 hydroxyl ions are here and 2 H2O. Beta, here also you balance it, it will be 2 hydroxyl here. So now in both the cases you have balanced chemical reaction. See what is overall reaction. In both the cases 2 electrons are there, they'll be cancelled. So just add the 2 reaction, cadmium plus nickel dioxide plus 2 electrons will be cancelled, and this is 2 water. This gives rise to cadmium hydroxide plus nickel hydroxide. 2 hydroxyl ions will also be cancelled. So this is the overall reaction. So 6 things we have done: anode, cathode, electrolyte, anodic half reaction, cathodic half reaction, and overall reaction. I've already told you the usage as well as what is the advantage of this cell over lead storage battery. Let's discuss the next type of cell, which is fuel cell. What are fuel cell? When a fuel is burned, by the combustion of fuel, some energy is produced, which is chemical energy, which get converted to electrical energy. So fuel cells are the cells in which chemical energy produced by the combustion of fuel get converted to electrical energy. As this is also a kind of redox reaction, so this energy can be utilized. And one of the example is hydrogen oxygen cell is there. And such type of cell was first used in Apollo mission, moon mission I am talking about. And when you'll see the reaction, you will come to know that the final product which is formed in this reaction is water, which was used for the drinking purpose by astronauts. I'll show you the construction and then the reactions which are occurring at this. Just take a container. We'll take 2 porous carbon rods. These are the electrodes. These are carbon electrodes. Porous carbon electrodes, and in between the two, electrolyte is there. This is here aqueous KOH. From this side, hydrogen gas is bubbled inside, which is acting as anode, and from this side, oxygen gas is bubbled, which is acting as cathode. So this is the arrangement. So anode is hydrogen, cathode is oxygen, and electrolyte is aqueous KOH. See, what is the reaction which occurs at anode and cathode? At anode, hydrogen reacts with OH minus. This reaction is carried out in basic medium. So this reacts with OH minus and changes to water. Oxygen on both the side is, the oxidation number is -2. But in case of hydrogen, here it is in the elemental form, it is 0, whereas it is +1. There is increase in oxidation number. 1 electron change is there, but there are 2 hydrogen. So there is 2 electron change. 2 electron it will lose because it is undergoing oxidation. Oxidation means loss of electron. Otherwise also we write down the electron on the side where the oxidation number is more. So here it is more, so I'll write down electrons here. Just balance the reaction. If I balance the reaction, I'll write down 2 here and 2 to 4. This is 2 here. This is the balanced chemical reaction. See what happens at cathode. At cathode, reduction occurs. Who is acting as cathode? O2. O2 here changes to OH minus. Just add water on both the side and you will come to know, you can balance it. But before that, let's find out the change in oxidation number. This is 0 here, oxygen in the elemental form. Here it is -2. When one oxygen changes from oxygen to hydroxyl, 2 electron changes there, but there are 2 oxygens, so 4 electron changes there. and there is decrease. Decrease in oxidation number means reduction. Reduction means gain of electron. It will gain 4 electrons. And now if you balance the reaction, it is 4 here, 4 electron, and you will write down water also, H2O. So now it is 2 water. So it is 2 to 4. Now it is balanced chemical reaction. So hydrogen is undergoing oxidation, oxygen is undergoing reduction. Can you write down overall reaction? Beta, here it is 2 electron change, whereas it is 4 electron change. So multiply this by 2 so that equal number of electron changes there, and there should not be any electron in the overall reaction. So it becomes 2H2 plus 4OH minus, 4OH minus get cancelled, here also 4OH, here also. So 2H2 plus O2 gives you 2H2O. This is your overall reaction. So the water which is produced as the end product was used by the astronaut as, it is the pure water. It is potable water. See, what is the advantage of fuel cell? One, you can say it will never become dead, because continuous supply of hydrogen, oxygen, as long as it is there, it will keep on producing the chemical energy, which will be converted to electrical energy. Then you can also say its efficiency, theoretically it should be 100%. It is highly efficient cell, although practically if you see, it is not providing 100% efficiency. It is only you can say 60 to 70%, whereas the usual cells, the conventional cell, they provide efficiency only 40%. Efficiency means output by input. So more output is there, that is why their efficiency is 60 to 70%. But in conventional cell, the input is more as compared to in this case. And it is eco-friendly also, you can say, because no pollutants are produced, and even pollutants are not used in this case also. In other cells, it is very difficult to dispose of them. Even in lead storage battery, dry cell, their disposal is very difficult because they contain poisonous substances. But in this case, it is eco-friendly. The product formed is only water, and the substances which are used is only hydrogen and oxygen. So children, let me revise what we have done. Today we have discussed different type of batteries: primary, secondary, and fuel cell. Fuel cell are also a part of secondary only, but I have discussed it under separate heading. In primary cell, they cannot be recharged, and that is why they cannot be reused also. First one is the dry cell, and in this case, if you see, anode is zinc container which is there, and cathode is manganese dioxide which is there along with the carbon. Electrolyte is ammonium chloride and zinc chloride, it is a paste. And these are the reactions which are occurring. It provides a varying voltage of 1.25 to 1.5 volts. And during this reaction, continuously there might be some holes which occur in the zinc container because it reacts with ammonium chloride. And through those holes, white stuff may come out, which will spoil the electronic device in which they are kept. So in order to avoid this, some plastic or some plastic sheet is attached along with it. And nowadays they have improved the quality of dry cells also. They are called dry cells because all the things which are present here is only dry. There is no water present in it. But in this case, some ions are present in the overall reaction. That is why it gives a varying voltage from 1.25 to 1.5 volt. Coming to the next cell, which is mercury cell, they provide a constant voltage of 1.35 volt used in hearing aids and watches. So anodic cathodic reactions are there, but the special feature is that they provide a constant voltage of 1.35 volt because there are no ions in the overall reaction. Coming to the second part of the topic, which is secondary cell, two we are going to discuss. One is lead storage battery, in which anode is lead, cathode is lead dioxide, and see how the reaction is carried out. In both lead as well as lead dioxide, lead sulfate is formed, and this lead sulfate white powder get deposited over the electrodes, and due to which efficiency of cell keeps on decreasing. So continuously discharging of battery is there. After few days or months, there is a need to recharge the battery depending upon the usage. And how will you recharge it? You will connect it through the external source, and then electrons will move in the opposite direction. Previously it was electrochemical cell, now it becomes electrolytic cell. पहले क्या हो रहा था? केमिकल रिएक्शन से इलेक्ट्रिकल एनर्जी प्रोड्यूस हो रही थी, बट नाउ chemical electrical energy will be provided from the external source and chemical reaction will occur. What kind of chemical reaction? जो भी discharging में हो रहा था उसका opposite reverse reaction होगा. एनोड पे loss of electron हो रहा था, बिल्कुल उल्टा हो जाएगा reaction. So now it is gain of electron is there. So cathodic reaction will be there, it is reduction, and now it becomes a negative terminal. कैथोड पे जो reaction हो रहा था, जब ये उल्टा होगा, so it becomes loss of electron. So now it becomes an anodic reaction. So this is there. Overall reaction also you can write down if you want in this case. And when discharging of battery is there, during this water molecules are produced which will dilute the sulfuric acid which is acting as an electrolyte. So but during this reaction more and more sulfate ions will be produced, and these sulfate ions will again maintain the density of or the concentration of sulfuric acid. Then we have also done the next secondary cell, which is nickel cadmium cell, and they are used in calculator. They have longer life than lead storage cell, though they are expensive, but they are also rechargeable. Fuel cells are the cells which convert chemical energy produced by combustion of fuel into electrical energy. One common example is hydrogen oxygen cell is there, and these are the anodic cathodic reaction. They are highly efficient and eco-friendly. बेटा बहुत बार बच्चे क्वेश्चन पूछते हैं कि हम कार बैटरीज में पानी क्यों डालते हैं. सो यू नो ड्यूरिंग द प्रोसेस ऑफ इलेक्ट्रोलिसिस water also undergoes electrolysis and it get converted to hydrogen and oxygen. So some water is lost. So just to make up for that, there is a need to add water. But nowadays, better batteries are formed in which there is no need to add water. Then you might have seen in cold weather, that is in winters, batteries get discharged very quickly. So again you can say due to lowering of the temperature, the chemical reaction which is proceeding becomes very slow. So that is why they get discharged and they can't make up to that chemical reaction which is required for the production of enough current. Beta, nowadays some lithium ion batteries are also there which are used in your mobiles, iPads, computers. Although this is not in the syllabus, but children generally inquire. So they are also very popular because of their lightweight and their safety characteristics. And in this case also you'll say anode is made up of graphite and cathode is some layered oxide of lithium. It is lithium cobalt oxide, and electrolyte is lithium perchlorate. So this is all about batteries. Children, please learn all these reactions. It is not easy to learn all these reactions in one day. So keep practicing. Write down all the reactions many a times. And we are left with last topic, that is corrosion, how to prevent it and the mechanism of corrosion. Thank you.